Yes, sir.
So, what did we learn in the previous class? We learned about different types of shapes, actually quadrilaterals, and the properties.
Yeah.
So, now we want to just touch upon some of the basic concepts of few more shapes, and then we will jump on to deriving the formulas for area and perimeter for all the different shapes that we come across. Okay? Yeah. So I'll not just tell you that this is the area, this is a formula for the area, but we'll also try deriving how that formula came into existence. So that way it gets stuck here. Okay. So now we know that polygon means shape with multiple sides. Okay. Any shape, any closed shape with more sides is called a polygon. Yeah. Now, so that means triangle is a polygon.
What, sir?
No, I'm just saying. So triangle is a polygon.
Yeah.
Any quadrilateral is also a polygon because it has many sides. Now, triangle quadrilateral we saw. If it has 5 sides, that is a pentagon. Yeah. 6 sides.
Hexagon.
7 sides.
Septagon.
So, okay. So we all know this. Now, other thing that we just wanted to keep in mind is, if I say area, this is the space taken by the object on the surface. Yeah. If I look at this as an area, as an object or shape, this is the whole area. If I join these two corners, now the area of this rectangle or quadrilateral is area of this plus area of this also. Yeah. It's like you have a piece of paper, you are breaking into two pieces. This area of the first piece versus area of the first piece and the area of second piece is the total area. Now let me give you a live example. This is a like a quadrilateral. Area of this quadrilateral, if I convert that into two triangles, meaning I break it into two pieces. This triangle and this triangle together make this quadrilateral. Yeah. So you have two options. If you know what is the area of this quadrilateral, wonderful. If you don't, if you know the area of this triangle and area of this triangle, you can add them together and that becomes the area of your quadrilateral. Yeah. So I wasted a little bit of paper, but there was a reason for doing so. Now, why I was telling that, why I was doing all that circus and drama was because that is where we talk about composite shapes. If I tell you, so let me just force you to memorize the area of a triangle for just for a little bit, okay? And then we'll come back to it. Area of a triangle is
half base times height.
Base times height. So anyways, you already know it, so I'm not forcing you. Alright. And then area of a rectangle is
length into breadth.
Length into width. Yeah. Now, if you have to find out the area for a triangle, you know the formula. If you have to find out the area for a rectangle, you know the formula. Nobody in the world will tell you of this shape.
The weird hexagon.
Hexagon, I don't know. 2, 4, 6, yeah, hexagon, yeah. But no, there's no way you can find out the formula for area of this guy. But you always have an option. You join the vertex and try breaking this into simpler shapes that you are comfortable with. Now what do you see? One triangle, two triangle, three triangle, four triangles. And you anyways know the area of a triangle. So find out area of this triangle, area of this triangle, area of this triangle, area of this triangle. All these triangles put together will make the area of this shape. And you don't have to memorize any new formula. When a shape is made of multiple similar shapes, or when you can visualize a shape as a mix, as a group of multiple simple shapes, that is called composite shape. This is composite shape. Yeah.
Okay.
So that's, and when people say find out the area of a composite shape, it's no big deal. You just have to break it down into simple shapes. And the best way to do it is join the vertex. Join all the vertex. Okay, or join the opposite vertex that way. You can join it this way, or if you want to do something more adventurous, you can do this way, yeah. Anyways, any which way you can break it down, yeah. And
Yeah.
convert that to simpler shape. Now let's go back to the basic. If you say, let's start with a rectangle. We all know a rectangle is nothing but a quadrilateral with opposite sides parallel and equal to each other. So this one is equal to this one is equal to this one. Yeah. Imagine now let's break it down. Let's say I have a square here, 1 centimeter in length, 1 centimeter in width. It's a square, right? All sides are 1 centimeter. Yeah. What will you call this guy?
Polygon.
No, polygon. That's a generic term. This is a square. If you have to say this,
Quadrilateral.
I'm sorry.
Quadrilateral.
It's a quadrilateral again. Yes, you're right. But I'm saying this is a square. 1 centimeter, 1 centimeter. All sides. Yeah. So it's a square with all sides as 1 centimeter. Yeah. Can I say it is 1 square centimeter or 1 centimeter square? It's a square with 1 centimeter. 1 centimeter square. Why I'm saying 1 centimeter square? Because every side is 1 centimeter. So this square is made of every side being 1 centimeter. Yeah. It's a 1 centimeter square. Yeah.
Oh.
I'm just giving you just the English part of it. Okay. There's no maths so far. I'm saying this is a 1 centimeter square. Yeah. So that is what becomes my smallest unit. So now you look at this, a rectangle, okay, which is 2 centimeter in length and 1 centimeter in width. Okay. Now this is a rectangle, okay, 2 centimeter length, 1 centimeter width. Okay. Let me break this into two equal parts. Now what happens? This is one square and this is another square.
Yeah.
Now again go back to my same theory. Now we have 2 centimeter squares. Yeah.
Yeah.
2 centimeter square. Now you think about it. This is another. I made the rectangle bigger. I have
3 centimeter square.
Yeah, 3 centimeter and 1 centimeter. It's a 3 centimeter square. Now, if you, let's say, make it double. Now, how many centimeter squares you see here?
So 6.
6 centimeter squares you see here, right? There are
Yes.
6 centimeter squares here in this shape, right? Which is a rectangle with 3 centimeter in length and 2 centimeter in width. So that is what becomes your basis for the area of a rectangle. Now what do you see? 3 centimeter square here 3 centimeter square here. Meaning this rectangle has 3 centimeter in length and 2 centimeter in width. You multiplied this 3 centimeter into 2 centimeter. That is how you got 6 centimeter squares. Yeah? Yeah? So basically, an area of a rectangle is nothing but you actually break it down into how many units, how many squares of single unit are there. If I say 5 centimeters length and 4 centimeters width, that means, yeah, so you actually even visualize this as a shape which breaks down into 20 centimeter squares. Yeah?
Yeah.
So that is what becomes your formula. So basically you say, okay, area is nothing but 5 into 4 because I have that many square centimeters, right? Yep. So that is how it becomes area equals area of rectangle is length times width. Length times width, because if you visualize this as a single unit squares, this many square units you will have there. Okay. So this was the origin for the area of a rectangle. This part is fine, right?
Mm-hmm.
I mean, there was no rocket science here. I was just helping you visualize this in a different way. That's it. Yeah?
Yeah, I get it. Like,
Now,
it would be easy on graph paper.
yeah. Because see, the problem is we all are gifted to memorize things. I mean, our brain is so powerful that we can memorize a lot of things. But then, memorizing things is not a bad idea at all. But then, do you want to memorize everything or you want to understand something so that you can relate later on? Right?
Understand, of course.
Yeah. So now, coming back to square, actual square. Again, if you look at this actual square, let's say it's a 3 centimeter length, 3 centimeter width. You can visualize this as a shape with 9 of those unit squares.
9 centimeter square.
Yeah. So that is why area of rectangle, area of a square is length times width or length times length, because your length and width are same. So that is how this gives you 3 times 3, 9. Yeah. This part is okay, right? Now, so let's move on.
Mm-hmm.
Now comes area of a triangle. So let's start with an easier one. This is a rectangle. If I join the two opposite vertex, what do I make?
A triangle.
I'm splitting that into two right angle triangles. Right angle triangles.
Okay, yeah.
Now, look at these two triangles. Are they same?
Yeah.
They are same, right? And this is where the theorem of congruence comes into picture. Do you remember the theorem of congruence?
Like, if one angle is big, then the other, the line that's opposite to that one angle is also big.
Yeah, that is the correlation.
Okay.
Yeah.
Side, angle,
Yeah.
I literally had a test on that yesterday.
Yeah.
I cheated it.
Yeah, so this is called theorem of congruence. These are the 4 theorems which tells you the different scenarios when two triangles will be congruent to each other. Again, as I was saying that Sally and Viren cannot be congruent. We don't have matching properties, right? When we say the two triangles are congruent, meaning they are exactly the same. Their properties will be same, their area will be same. And you don't have to necessarily match everything. If you have certain conditions met, that also proves them congruent. Okay? And there are 4 theorems of congruence. If I can help you recall them quickly. Two triangles, all the 3 sides matching.
Side, angle, side, angle.
two angles, this angle is equal to this angle and this angle is equal to this angle, and the side between them, the side between the angles, okay? If they are same, then you can assume that it's the same triangle. Yeah?
Yeah.
And I can prove that. We'll prove it later, okay? I mean, it's easy. I mean, otherwise the whole class will be gone proving the theorem of congruence, okay? Then the third one is, if you have two triangles with the two sides matching, meaning this side and this side, this side and this side matching, and the angle between them matching, then they are congruent. Yeah? And this one is for right angle triangles only. R stands for right angle triangle. In case of right angle triangle, if the hypotenuse and one of the sides are same, then they are congruent.
Oh.
Yeah?
Isn't it HL, hypotenuse like?
Hypotenuse, yeah, H is hypotenuse and S is side.
Oh, we write HL.
Oh, HL, that's fine. I mean,
That's the same thing.
it's the same thing. What it essentially says is, if you have two right angle triangles, hypotenuse is same and one of the side, any of the side, okay? Any of the other two sides are matching, then those two triangles, those two right angle triangles are congruent. Now, here, when we looked at this quadrilateral or rectangle, right? See again, now it becomes important, right? We were saying, last class we were talking about the properties of the shapes. Now, when we look at rectangles, we know that every angle is 90 degree. This is 90 degree, this is 90 degree, this is 90 degree, and this is 90 degree. All the angles are 90 degree. Opposite sides are equal and parallel to each other. So this side is equal to this side is equal to this side. Yeah? Now, what I was trying to do was that we had a rectangle. We just join the two opposite vertices. That split that to two right angle triangles. One is here and one is the above one. What I am saying is, these two triangles are congruent. Why? Because your hypotenuse is anyways common between both the triangles. And the opposite sides are same. So this side you should pick, that is also same. So this condition qualifies. Yeah?
Yeah, of course.
So they are congruent, meaning area of this triangle is equal to area of this triangle. Yeah?
Okay, yeah.
Or I can say area of this triangle plus area of this triangle is same. Sorry, area of this triangle and area of this triangle are same. And we know that if this is area, let's say A1. Okay? This will also be A1, same. These two areas are same. Now look at the area of the rectangle. Area of rectangle is what? Of rectangle is length times width. Length times width. Or here what we see, the area of rectangle is A1 plus A1 equal to length times width. Meaning 2 times of A1 is equal to length times width. Or A1 equal to half of length times width. So, summary is, I have a rectangle, I know the property, all the angles are 90 degree. I join the two opposite vertices, that breaks it into two right angle triangles, and these two triangles are congruent by this theorem. So if they are congruent, meaning the area of this triangle and the area of this triangle are same. Two equal things are making this right angle triangle. Rectangle. These two equal right angle triangles are making this this rectangle. So area of the one triangle is half of the total area. Yeah? The total area is length times width. So area of one of the right angle triangle will be half of the total area. Half of length times width. Half of length times width. Or if you look at this as a right angle triangle, this is your base, this is your height. Yeah? Half a base times height.
Sir,
Mm-hmm.
get that. I have a doubt regarding congruency.
Mm-hmm.
Well, I was doing this document for school
Mm-hmm.
tonight, and I was just checking my answers.
Okay.
Wait. Can you see my screen?
Sure. No, you'll have to read it for me. Okay, yeah.
Oh, there's a
Let me
diagram,
get
so
closer to it. Okay.
give me 1 sec. Give me a second.
Okay.
Can you read it now?
Yeah, I'm able to. SAS.
So, for the ninth question,
Uh huh.
the answer is none, but I wrote SAS. So, can you just tell me why is it none?
EX bisects TEM. T TEM or TXM? Okay. Sorry. EX by. Okay. Fine. EX bisects. Okay. Okay. Number 9, right? Okay. I'm looking at number 7 right now. EX bisects TEM. This is fine. So if it bisects, the two angles are same.
Yeah, so it's SAS.
And then this is common, and T TE TE is similar okay, line T is similar to this one. What does it mean, this one? The number 7, the last part of the question, if you read it for me, what does it say?
EX bisects TEM.
Uh-huh.
TE is congruent to EM.
T is congruent to EM. Okay, yeah, this one is fine. Yeah, now let's look at this one. Number 9, TX is congruent to XM. TX is congruent to XM. Okay, EX bisects TEM. Okay. EX bisects TEM. Okay, let me just draw it here on the board. Then it'll be easy.
Sure.
TX is congruent to XM. Okay. EX bisects TEM. And give me 1 second to draw it. TX XM. TXM. And then EX. Yeah. Okay, now it's fine.
Okay.
So it says TX is congruent with XM.
Yeah.
TX is congruent with XM. Okay. And then EX bisects TEM. So this one bisects this one. So this angle and this angle are same. So what you have got is one side matching. Here.
So
SAS would need two sides, side, angle, side.
yeah, so the three lines that we considered a side.
Okay.
And I'll just
Okay, see, here's the catch. Now SAS, when you say side, angle and side, meaning the two sides and the angle between them. Here what is the situation? This side is common, okay? So one side is matching. This side are matching. But see where the angle is. Angle is here. So you have sides here, angle here. If this would have been this angle, then side, angle, side. Side, angle, side. So if you now go back to number 7. Go back to number 7. And show it on the screen again. Okay. Closer. Okay. EX bisects TEM. Okay. No, TEM. Yeah. What is the difference between both the questions? 7, 9.
Okay, so 7 is basically, give me a second, let me just read it. EX bisects TEM, TE equals to EM, TX is congruent to XM. Okay, so 7 is basically the short one, so the short lines.
Oh,
Yeah.
T equal to EM, yeah, see. So that is where your answer was right. Because T equal to EM, when you are given these two are same and this side is common, see the angle is falling between the two lines. Okay, so that is what this says. SAS, side, the angle and the side, meaning the two sides, the angle is between the two sides. That is the catch. You don't say SSA, you don't say, you never say this. Okay, so this one, the angle is between the two sides. That is the catch here. So when you look at 7, it said EX is bisecting this angle. This is the case. This angle are matching anyways. Now this side is anyways common. So when this side and this side are being asked congruent, then your situation is matching side, angle, side. Side, angle, side. Then they are congruent. Here in this case what happened? EX is bisecting this one. These two angles are matching. But it says TX is congruent with this one. So just one side is here, angle is here, then this side is here. Angle is not falling between the sides. See, visualize this way.
But we know it's congruent, so we cannot mark it by ourselves.
No, you cannot. You cannot. See, you see my drawing skills. Do they look congruent at all? No. Right? You are being forced to believe because I'm saying the properties are matching. So imagine whatever you see on this, optically, whatever you see there, don't go by that. Okay? Go by what is mathematically proven. What you can prove mathematically. This theorem is very strict, very, very strict. It says side, angle, and then side, meaning the two sides are making that angle. In case of 7, you have this side and this side making this angle. So side, angle, side. This side and angle and this side. Since you were told that this side and this side are congruent, this is anyways common and this angle are same because this is bisecting the angle. So that is how you get side, angle, side. Side, angle, side. But if you are saying that these two angles are same and these two sides are same, so your side is here, other side is here, angle is here. If the angle would have been here, it would have said that EX is bisecting this angle, TXM, then this would have been SAS.
Yeah, I get it.
So,
yeah.
Yeah, go ahead.
No, it was just another question, but you can, continue.
No, you tell me, ask the question, that's okay. I am not doing any race. My job is to make you understand things, okay? Yeah, tell me.
Yeah, okay. This is my last question. So this is a diagram. I just want to know, why is it ASA?
Why it is ASA? It's a parallelogram, right?
Yes, parallelogram, but they did not mark any angles. They only marked the sides.
Yeah.
And they also share a common hypotenuse. So how is it ASA?
Okay, let me draw a parallelogram first. This is a parallelogram. When you say parallelogram, what you say always is this.
So they mark all the parallel lines. So basically, opposite sides are equal to each other.
They are equal and they are parallel.
Yeah.
They are equal and they are parallel, okay?
Yeah.
First of all, this is SSS also, okay? Because all three sides are matching.
Yeah.
this is side equal to this side equal to this side, and this angle is common. So SSS is given if it's a parallelogram. Okay. Now you can say that it is SAS also. Now how? Look at this. These are parallel lines, and this is a line intersecting them. When we are looking at the parallel lines, what did we see? The corresponding angles are same, okay, and these two also same. Yeah.
Alternate interior angles.
Alternate interior angles. Now visualize these two as parallel lines, and this is an intersecting line. So this angle will be equal to this angle. Yeah. This angle and this angle will be same, right?
Yeah.
Alternate interior angles. This is parallel line. This is intersecting line. So now you have SAS.
Yeah.
So here you can prove two theorems actually, by SSS or SAS, both.
Okay. Yeah, but they said ASA. How did they get ASA?
ASA also you can get. Now, if these two angles are same, do you think this angle and this angle are also same?
But you told me to not assume something because
not. You're not assuming. I'm proving it. You're not assuming. So see, if you simple thing, I have two parallel lines. This line intersecting. This angle will be equal to this angle. This angle will be equal to this angle. These are alternate interior angles. Yeah.
Yeah.
So now visualize this. I'm not saying that you have to assume here. What I'm saying is, don't look at anything else. You are just saying, okay, this is my parallelogram, meaning two pairs of parallel lines. Yes? Yeah? If I am joining these two corners, it's like two parallel lines, this is my intersecting line. So if I am looking at these two parallel lines, this one and this one are my alternate interior angles. If I look at these two parallel lines and this is my intersecting line, then these two becomes my alternate interior angles.
Oh, yeah.
So you have to change your what do you call it? The alignment of your eyes. That's it. You are looking at from here. These two are your interior angles, alternate interior angles. Change your alignment of the eyes. Now these are two parallel lines, and this is intersecting line. So this and this are the alternate interior angles. Yeah.
Got it.